Questions about homology are really tricky because they tend to be exercises in circular definition. What do we mean by homological organs? Well, in the 19th century, in the early 20th century, geneticists and biologists struggled to put together a criteria for homology. They talk about similarity in embryological development, similarity in function, similarity in morphological form. That's reasonable, but a little vague, a little unclear. But what inference do you make from the fact that, say, the fin in a fish is structured in a way that's remarkably similar to the hand in a human or in a chimpanzee? If the fact that you see some morphological significance is taken as evidence for common descent, there's not much additional that you need to look for by way of evidence because the issue is definitional. If it's not taken as evidence for common descent, what do you need to complete the inference to common descent? There are plenty of examples of homological structures in biology which are obviously not based on common descent. For example, take the Australian wolf, which, except for the reproductive system, features a wide variety of organ systems that are absolutely homological to the North American timber wolf. But there's no evidence that these homological structures arose because some wolf at some time in the past, or some proto-wolf, decided first to migrate to Australia and then to migrate to North America. The evolutionary lines are completely distinct, and yet we see a profound degree of homology. We see this throughout the animal kingdom. The whole issue of homology, commonality of form, is riddled with a great deal of philosophical uncertainty because it's never clear what the evidence is for, and how one is to avoid completely circular reasoning. What is clear is that within family groupings, there are profound similarities in structure. We can say that. But whether they arise because of some constraints in the circumstances of life, or because there's a genuine explanation in terms of a common ancestor, we just don't know in many cases. The entire mammalian group of animals, for example, all of the mammals, have many, many properties in common. Why this should be, we don't know. For example, the pentapod nature of all extremities. Why is 5 preferred in the mammalian kingdom and not 7 or 13 or 52? It's an obviously interesting question. If we say that it is because the mammalian organisms were derived ultimately from fish, then we have a profound number of problems in that pectoral and pelvic girdles also obey the rule of 5. They also obey the rule of 5. Where did this constraint come from? It's not entirely clear.